If this is your first time watching through Inquisitive Kids, welcome to our channel. In this video, we will be starting word rearrangement, another large topic under our AMC8 course. So previously, we already learned all about permutations and combinations. So if you haven't watched those yet, I will be linking those in the description down below because permutations and combinations are what's going to build up to what we're going to learn in this lesson, which is word rearrangement. Word rearrangement has permutations in it, so you can almost think of it as a special type of permutations problem. But this specific type of problem has appeared many times on AMC8 tests before, so that's why it has its own category, word rearrangements. So basically they're permutations with words. But many of these skills that you're learning can be applied to other permutations problems as well. Maybe they're not letters, maybe they're balls, maybe they're gumballs, maybe they are cards. There's different ways that you can think about this. But for now, let's stick with what are word rearrangements and what is the formula that we use. Let's first start with looking at this first example. So we have a word and it's pencil. How many ways are there to misspell this word pencil? By misspell, it just means to reorder the letters. So we know that there are 6 letters total. So 6 spots for the 6 letters. Let's start with the first one. How many different options are there for the first one? Well, you still have 6, so you would have 6 options. For the next one, since you already used one for the first one, you would have 5 options and then 1 less, which would be 4 options, 3 options, 2 options, and then 1 option. After multiplying this all together, this is 30 and this is 24, you get 720. So there are 720 ways to misspell the word pencil. Now let's try another problem. So far this is pretty easy if you are someone who has watched our permutations videos. So let's look at the word bunny. How many ways are there to misspell this word? So we can see that there are 5 letters in the word bunny. So we can still use that same way that we just used before. The first one will have 5 options, then 1 less, which is 4 times 3 times 2 times 1. This gives us 60 different ways. But let's think about it. Is this really the correct answer? Because remember, there are 2 N's in the word bunny. If you respelled it like this, that would be one way you could misspell the word bunny. But is that really different than if you misspelled it like this? So we have labeled the N's as N1 and N2. So are these the same rearrangement or no? Well, in this case, there are no different N's. N is the same letter. So if you have a letter that repeats, what do? It means that we must have double counted instances like this, somewhere in the 60 ways. So what's one way we could do this? This is where our formula comes in. Let's study our formula. We have n factorial over a series of d, so d1 times d2 times d3. What do these variables mean? Well, n is the number of ways to rearrange the letters, ignoring the repeated letters. So that would be exactly what we just did, so how we got the 60 ways. Since there are 5 letters, we just have 5 factorial as our numerator. Now what about d? Well, we see that there is 1 letter that has been repeated, n. And how many times has that letter been repeated? 2 times. So our d in this case would be 2. In this case, we only have 1 D because there is only 1 letter that has been repeated. If the B was repeated, for example, then we would have 2 times 2. Or depends on how many times that the letter B would have been repeated. But in this case, we have 5 factorial over 2, which is 720 over 2, which can be simplified down to 360. So for the second problem, our answer would be 360 ways. So this is the formula that we will be using throughout the 4 word problems that will be coming up after this video. it's really important that you memorize this formula, and memorizing this formula will help you solve future problems much easier. But again, when it's called word rearrangements, remember, it doesn't just work with letters and words. It can also work with any other type of permutations problem as long as one item in the permutation repeats. That's always a time when you can stop and you can think if this formula can be applied. Thank you so much for watching 3 Inquisitive Kids. We'll see you next time.